So really quickly here on this guy, just a quick overview. I don't want to go over the factoring part. Hey, I don't want to go over the factoring parts, but as you can see here, I found my equivalency statement where it says combined area of both is 6. I built it out and factored each piece. So from here, I would then write out the actual setup. I'm going to use a different color here. I'm basically just going to rewrite this guy here, but all the factored forms of it. Okay? Yeah. So 2x minus 1 plus, because it said the combined area was 6, so add. I'm just going to double check. I don't want to screw this up. 3x minus 2, 4x plus 3, all over 4x plus 3, x minus 2, and all that's equal to 6. So before I get into my addition statement, I'm obviously going to try and cancel this stuff out. This is why we do this. So if you go through that list that's on the board there that you can't see on this video, find equivalency statement, build the statement, and here, because it's a wrap, we will go to factor and simplify first before we go to set to 0. So now those two things disappear, and then those two things disappear, and I can rewrite everything now as 2x minus 3, x minus 2, plus 3x minus 2, all over x minus 2. Phew, isn't that a lot easier?
I got to there, but do I have to times both of them by the denominator?
No. So here's what's nice about this guy. Because the denominators were the same, because this is an addition of rats, we're basically just going to combine them together. So I'm just going to have at this point 5x minus 5 all over x minus 2 is equal to 6. Now I can solve for a value of x. This guy's actually not going to be bad. This is where I'm going to do my, Alex, you preferred me saying cross multiply. I hate this guy on the bottom. He's just going to get brought up over here. Exactly. 5x minus 5 is equal to 6x minus 2. So 5x minus 5 is equal to 6x minus 12. And then now I can just rearrange and solve for stuff. So bringing this guy over and bringing this guy over, x is going to be equal to positive 7. So that one's a lot easier, right? I will point out as well is on other versions of this, factor, simplify, combine, set to 0, you may still have to do factoring of a trinomial at this point. But this one's a little bit easier, right? They're all a little different, but I'm hoping you can get down to at least this step and then utilize that guy. The x, now I have a value for x, which I can then plug into a easier simplified version so I can find the numerical area of the new deck. Basically what I would do is I would plug x is 7 into the simplified version of this guy right here, because that's the simplified version of the new deck. I'm lazy. I don't want to actually do more work than I have to. So 3 times 7 minus 2 over 7 minus 2. So 21 minus 2 over 7 minus 2. It'll give you something ugly. 19 divided by 5, but that's the numerical area.